Hello everyone. This lesson is on solving inequalities of combined functions. So we're going to consider the general inequality f of x is greater than g of x when we compare when one function is greater than another. Okay, and we're going to show several ways to do this. Okay, and the key thing is it says illustrate here. Okay, so in the note, we're going to be talking about how to solve this when the two functions don't really mesh well together. Like, for example, if both f and g were polynomials, like say they were both quadratics, we could do that algebraically. We did that in Unit 1. Like, you could get all the terms on one side, tidy it up, factor it, interval chart. Okay, we can do that already. Same with polynomial and rational. Okay, that would be okay. But if we start mixing functions together that don't normally go together, right, you know, trig, exponential, log, and a polynomial, okay, it's going to be difficult to do that algebraically at the moment. Okay, so we're going to be looking at cases where we mix them together a bit. So for example, we're going to look at 9 minus x squared is greater than 2 to the power of x. Okay, we're going to be doing this with technology. So either on your own device, you should have Desmos handy so you can follow along and try it out. Okay, or of course, you can grab an iPad from the card at the back of the classroom and use the Desmos app on there. So again, we're just going to show 3 different visual ways you can look at this. Okay, the first one is just to look at f and g separately, okay, and use Desmos to interpret what's going on. So in this case, if we stick to the same format in the top line there, okay, this means that my f of x is going to be 9 minus x squared, and my g of x is going to be 2 to the power of x. Okay, and I want to see when f of x, right, is greater than g of x. So I'm going to switch over to Desmos and put in those 2 functions. Okay, I'm just going to double check. 9 minus x squared and 2 to the x. So there's your 2 functions. Okay, I wanted to know when f is greater than g. So that would be in this stretch here, right? That's when my parabola is above the exponential function. So all I really need to do now is read the information off the graph. Okay, the points of intersection are here and here. Okay, so from about negative 2.979 over to 2.142, okay, that is where f of x is greater than g of x. So my solution is really just going to be writing down the interval, right? So from negative 2.979 to 2.142. And so my solution is x is a set of negative 2.979, I think, and 2.142. Okay, right, that's approximate, but that's the interval where f of x is above g of x. Okay, and that's really all there is to it. Right? We're using technology to do this. Okay, that being said, if I asked you to do this by hand, okay, this wouldn't be too bad, right? You could graph the parabola by hand pretty easily, right? Find its roots. Okay, you could graph the exponential function. Okay, it's a basic exponential function. And then from your sketch, you'd have a rough idea what it was, right? You could say it's approximately between -3 and +2, and that would be a reasonable estimate of the solution. Okay. Okay. Second technique, okay, is to rearrange the equation and graph this new function. Okay. So just to bring it over, So again, I had 9 minus x squared, and now minus 2 to the power x, and I want to see where that's greater than 0. So I'm going to go back over to Desmos. I'll hide these for a second. So now I'm graphing y equals 9 minus x squared minus 2 to the power of x. Okay, see, it just kind of tweaked my parabola a little bit there. But now I've rearranged this, I'm really just looking for the roots, right? Where is this function above 0? Okay, well, there's the same number I had before, negative 2.979 and 2.142. Okay, so in some ways, this is a little easier visually to see what's going on because I just have to look at the roots. And right, if I'm greater than 0, I'm above the axis, and if I'm less than 0, I am below the axis. Okay, and it's going to have the same solution. Okay, our third option, okay, is we could rearrange this to a quotient and see when it's greater than 1. Okay, which I'll put a little more detail in here. Right, again, the idea is my function, I had 9 minus x squared is greater than 2 to the x. So, right, in the previous option, right, we move 2 to the x around by subtracting it from both sides. Okay, in this option, I'm choosing to divide both sides by 2 to the x. So 9 minus x squared over 2 to the x is greater than 1. So I now have 1 equals 9 minus x squared over 2 to the power x. Okay, and to see where that's greater than 1, I'm going to graph the line y equals 1 and find their intersections. Okay, and again, we get the exact same points. Okay, now, this technique, this third one, again, I'm showing it because it's in the textbook. It is a way you can solve this. However, you have to be really careful. Okay, part of the reason that this one works the same way as the other two is because of my denominator, right? This works well because 2 to the x is always positive, right? You might remember from when we were doing this stuff with rationals, if your denominator is negative, right? If you're multiplying or dividing an inequality by a negative amount, it flips the sign of the inequality. So this would not work well with other functions, like say if it was sine, okay, or most polynomial functions. If they have anything negative about them, it doesn't work great, okay? Again, it works here because 2 to the power x is always positive, and so I get the same roots that I had before. Okay, so realistically, I'm going to say if you're solving one of these problems on an assignment, okay, or doing the rough sketch on, say, a test, you're really going to want to choose option 1 or 2. Okay, option 1, right? If I was asking you to give me a rough idea what the solution was to this by hand, okay, then you would be doing option 1, right? You would do a rough sketch and say, okay, right, here's my parabola, it looks like this. Here's 2 to the x, it looks like this. Okay, obviously with a little more detail than I've drawn here. And then you could eyeball the solution from there. Okay, the second technique is important, again, I think, because if you go on to study calculus, okay, that's going to be probably the technique to solve those inequalities, is to set it one side greater than equal or less than equal to 0, and then solve it from there. Okay, so option 1 and option 2 are both really good. Okay, option 3 works in some cases, but it's not ideal. So I wouldn't recommend that one as often as the other two. Okay, so that's basically it. For another example of this, and again, I mentioned that, you know, if it's familiar functions, you can solve it algebraically. So I would like you to read example 1 on page 451 of the textbook. because it carries through, I think, with a quadratic and a linear function, something like that. So you can see the algebraic solution as well. Okay. But if it's a mixture of functions that we don't normally put together, again, you're going to want to use technology to solve those kind of problems. Okay. So for practice work, and I'm just noticing there's no page number there, so let me fix that. It's on page 457, numbers 3 through 9, 16, and 18. Okay, and again, like the idea here is to solve these inequalities, you're going to probably be using technology, okay, and that's totally fine. Thank you for watching, and we'll see you in the future.